Welcome back to the Saga Tech Gates. So in this video, we'll explore a random. It is a system function in Verilog. So a powerful tool for generating a random number during a simulation. In this video, you will learn what $random does and how it works, and also how to use this $random in a test benches. So what is a $random, how it works, and also how to use this $random in a test benches, and also behavior of assigned outputs, and how do we convert from negative outputs into positive outputs. We'll see all these in this example. Let's get started with $random. So a $random is a system function is used to generate a pseudo random numbers. Especially in the test bench, if you want to generate some random numbers, we are using this $random system function. Clear? So it returns a 32-bit random number whenever it is called. Clear? So if we call this a $random, then it returns a 32-bit random number. That number is a signed integer, or maybe it can be positive or negative. If we call the $random, it can return 32-bit signed integer. It may be positive or a negative. So the seed can helps control the random sequence. That means nothing but a same seed equal to same sequence. So the seed argument controls the number that a $random returns. The different seeds maybe generate a different random stream. So this seed argument shall be either range or maybe integer or maybe a time variable also. So the seed value should be assigned to this variable prior to calling this $random. Clear? So different seed will produce a different random stream. Clear? So it is not synthesizable. Remember, we'll use this $random only in the test bench, not for design purpose. That means it can only be used in the simulation. So not in a real hardware design. So now this is a simple syntax for this $random. So real value is equal $random. This seed is optional. You can write like a random value is equal $random also. So now we should declare integer rand value. The rand value is equal $random. After calling this random, immediately it returns 32-bit assigned integer. Clear? So we have another random function $urandom underscore range max comma min. So actually it is not available in Verilog. So it is a SystemVerilog system function. It should returns unsigned integer between min and max. Whereas this $random returns a 32-bit signed, where it $urandom range returns the unsigned integer. That is the range specified max and min. Those are inclusive. Clear? Now see this example here. So I define simple module. So in this, n shall begin display generating 5 random numbers. Just I'll use a for loop I equal to 1, I less than or equal to 5, I equal to I plus 1. So now how many times this will execute? This whatever the statement written in this begin and end in the for loop will execute how many times? 5 times. Clear? Every time I'm calling the 5 times this $random function, system function. Clear? So every time it generate different values and assign to this rand value. Now I'm displaying those values. Now what is the output for this program? Clear? If you see, so now generating 5 random numbers. Every time 5 times this $random generate 32-bit integer signed value. Okay, it's a maximum of 32 bits. So now it can assign to this rand values. Now see, these are the for each and every called, this $random is called, then it returns this value. So 5 times it returns 5 different values, including positive and negative. So now here we'll see how to generate a random number in a given range by using this $random. Now see in this example, so now we want to generate a value between minus 99 to plus 99. So the rand value equal to $random modulus 100. What is the meaning here? So now for example assume that this $random generate anyway 32-bit signed number. Clear? So now but we want a number between minus 99 to plus 99. So now if I use this one, for example this $random generate 299. If I use a modulus 100 means then 299 modulus 100 means, so always this modulus 100 returns the remainder. Clear? So 299 modulus 100 means it returns 99. Clear? For example, 300 returns 0. 301, for example, it random $random generate 301. 301 modulus 100 means 1. So if I use this modulus 100, then I generate minus 99 to plus 99 only. Understood? Right? So for example, I want to generate numbers from, okay, some 999 to 999, minus 999 to plus 999. So we use the 1000. Clear? So now we are restrict the $random. Okay, here not restrict, actually we are using this $random to generate a number in the given range. Clear? So here another here if I use a concatenation, if I use like this, okay, if I write concatenation random number, then it returns only a positive numbers, whereas it can return a positive and negative in the first statement, but in the second statement if you use concatenation operator here, okay, for this $random, so it returns a number between 0 to 99 only. It returns only positive numbers. Now see some example here. Now I'll define one module. Here I'll use $random modulus 100. What is the meaning here? Now anyway, I'm calling 5 times this. I'm calling this $random 5 times. But I use modulus 100. So what is the $random generate a 32-bit signed number. If I use modulus 100, then what is the range? Okay, we get here from minus 99 to plus 99. So now if you store the value in number, if you display, then this is the output. So now, so $random ampersand 100. In this case, so 5 times if I call, then I'll get the number, the random number between minus 99 to plus 99 only. So whatever the range you want, then you can change this value here. For example, if you change the 200, what is the range you'll get? Okay, minus 199 to plus 199, like that. Clear? So now same way if you use this by using concatenation operator. So in this example, everything is same, but I'll use like this concatenation operator. Okay, so inside that I'll write this $random. It generate five times I call this $random. Clear? By using this for loop. Now it generate 5 random numbers. So now what are the random numbers? Those are 48, 97, 57, 87, 57. All are positive numbers only. Whereas here simple random generate a negative numbers. If I use in concatenation operator, then it generate the only positive numbers. Clear? Now this $urandom range max comma min. It is a SystemVerilog system function, not available in the Verilog. So that returns a uniform random integer, that to 32-bit unsigned integer between max and min, and these are also inclusive. Clear? I'll show some example, right? Now here same way, if I call 5 times this function $urandom underscore range 15 comma 5, what it returns 32-bit unsigned integers. How many times I called? 5 times. So now we'll get a 5 different values, that two positive numbers. What is the range? 15 and 5. These 5 and 15 also included in that range. It may generate 5 or 15 also. Now what is the output? See now here. So output, yeah, first after first calling. So now 11, 12, 9, 10. So now this $urandom underscore range returns a uniform random integer, that to 32-bit, that to unsigned integer in the given range 15 and 5. Clear? It may generate 15 also, it generated maybe 5 also. Okay, those min and max also inclusive. Clear? That's it for today's videos on $random and $urandom underscore range min comma max in Verilog and SystemVerilog. So we saw how $random can use it to generate signed random values for simulation, and how to limit the range using a modulus operator. And also we also explored $urandom range, and it is safer and more flexible option in SystemVerilog to generate a random number with a specific positive range. So this $random for quick and simple random values, but with a care for negatives. Whereas this $urandom range When you need a clean and bounded positive values in the SystemVerilog test bench, we'll prefer this $urandom range. Thank you very much.